It was very good evening. So it has already been a 5 minutes after your set time. So we'll be starting this session right now. So whomsoever has joined it later, let's just pick up with along with your friends who has joined in prior. So today we are going to look something different, which is of a common topic, but this still like an when it comes to an engineering topic, it will be somewhat bit controversy topic. It's like combined of theory, but you have to the way how you are going to get it understand. That's how the matter it is, because even a small things, everything is going to be like a same. Whatever the concepts I'm going to teach for the next an hour, it will be of the same thing, looks like a similar thing, but there will be a minute small difference with you. So don't make a mistake, don't get confused over here and there. If you have any doubts, stop me over then and there, then just go ahead with your queries. Because all the sessions I used to say that once after finishing up the session, just talk with me or clarify your doubts or the queries. So as this is somewhat confused session. So if you have doubts then and there, stop me right there. Then just ask me. So we'll go ahead. So before getting on to the topic, why strength of materials? What is strength of materials? And how it is going to be useful for your future job or whatever might be right now you might be working on a company. How it is going to be useful? How SOM is useful for your future jobs. Don't get confused with the SOM. When it comes to engineering, SOM is strength of materials. When it comes to management, MBA, SOM means service operation management. So SOM has the two meanings. So don't go ahead with the management guy and say that SOM, I am aware about SOM. For the management people, their SOM is like service operation management. But for as of our engineering culture, SOM refers to strength of materials. So when would we call a material which is of strength? Uh, so are we going to say like so right now I have the water flowing out of a tap. I could able to keep my hand over there in between. But taken same example, if I'm going to have the water out of the dam outlet from the dam, I will I able to keep my hand over there. Same water is there. Same the person who is going to keep the hands over there in the water which is coming out of the tap, which is coming out of the dam as well. But what is a different matter is that force. The force where which the water comes out of the tap is lesser when compared to the force which comes out of the dam. The force is going to work as your external force, or else force can be said that your external force or else internal combustion. I'll tell you in later. Um, so it's like when an external force acts on a body, the body here, the body is refers to like a material. Maybe it can be silver, gold, copper, aluminum. When you are going to work with the turbine, like windmill turbine. So or else with your aircraft turbine, it is all made with aluminum for the lesser weights. So the place to place, your body, the place, the term body refers to that particular place. That can be of your water, as of I said right now. The example what I have given, the body was stated to the term water. But when it comes to the different scenarios, place to place, the term body gets changes. So whenever same will have the same example, the water is flowing towards a pipe. So I'm just it is on the luminar flow. It is like normally flowing. Whenever you are going to have your hands interrupted out of the water flow, the water's shape or else it is water is getting distracted out of its path. So that is what here refers to. The body tends to undergo some deformation. Deformation is nothing but it is going to change its actual size. So here everything will be in a common statement throughout this session. Wherever you go, even if you are going to refer to R.K. Bansal book, which is written in 1963, even for strength of materials, the things will be common for everything. That place to place, scenario to scenario, the your external force or your body, your deformation, everything is going to get changed. So we'll get back to the thing. When an external force acts on a body, so who is the external force? My hand is the external force. It is going to act on a body. body is nothing but the water. So the water tends to undergo some deformation. It is going to distract away from its path. That is what it is said in the first statement. So it is somewhat, it will be related to the physics terminologies throughout strength of materials. It will be related to physics. So it will be like body, external force, all the scenarios will be there. So due to the cohesion between the molecules, the body resists the deformation. The same water, if you are going to keep your hand on the pipe water and the dam water, it is the cohesion between the molecules is nothing but your force and the strength of the particular water which is coming out of the material is too hard. So the body resists the deformation. What is the body which is being compared to here is the water resists the deformation. If you're going to keep your hand in the mid of the water which is flowing out of the dam, the the particular water is will not take that much of risk, or it is not going to get distracted when you keep your hand over there. Obviously you are going to, the person, your external force is going to be the one which is going to get hurted. So for here, body resists the transformation. Such kind of things is called as strength of material. Material can be referred to anywhere, any places, any material. It should not be of a material. It can be of your like same like water. If I'm going to take like my even I'll say in many of the examples like plastic scale, steel scale, iron scale. So these are also materials whichever we are going to the daily day-to-day life. Your normal benches, your laptop, everything is the material as of now for us for strength of materials. Whatever the material, whatever the things you see, it is all called as a material. So if I'm going to punch the uh, desk or your laptop, obviously if you're going to punch your laptop is going to get deformed. That is, it means that it is going to get broken, or else it is going to get bent. Anything might happen. So that strength of material for the laptop is much lower when compared to when you punch over the desk or a wooden material. That particular material is not going to get deformed, or it is not going to get any of the shape changes. So that in that moment the strength of the particular material, strength of the wooden is much higher compared to the strength of the laptop, right? So the same thing is, so this is what means that strength of material. So we'll be explaining you what is called a stress. So with the normal terminology, what is stress? I'll come up with a normal, we used to say now whenever we go out for a job, whenever our classes are hectic, we used to say stress. We used to say that I have a tension. So I'll be explaining with the day-to-day life scenarios also, and then I'll pull into this topic. So how materials are getting deformed? What is the values? So if you are going to melt iron, that is going to, obviously if you're going to apply some external forces like hydraulic pressure or something else, it is going to get deformed, it is going to get its shape changed. But not that the as that when once the steel is being produced and it has came out, you're not able to make it. So that is what the strength of material differs. So how materials deform and how to prevent the failure. So what are the causes, like so if I'm going to punch the laptop, I need to know how much force should I need to put onto that. If I'm going to punch the laptop with the minimal force, uh, my laptop is not going to get damaged. So how to prevent these failures? So in this session, we'll be explaining about expansion, contradiction. Contradiction is nothing but your compression. It's a physics term which is called as a contradiction. And then stress, strain, and then your again it comes your stress, your tension. This is a torque. This is a tensile. Actually, I have made it wrong. Sorry. This is a tensile. So these all the things we are coming ahead with the normal terms, because the that stress, tension is not going to happen only for the psychological matters. It also happens for the non-living things as well. So how that is going to happen over there, and how to test all those things are called as a non-destructive testings. You have an category one, category two, category three, three categories of NDT papers, which is authorized by the central government. If you wanted to, I'm not promoting any of the exams. So if you wanted to go ahead with the non-destructive testings, you can go ahead with. You will be writing the two examinations. Category three examination will be for an instructor. So the particular test will be made on the particular material in order to prove that okay, this particular material has not have don't have any of the cracks or else like dent. This material doesn't do going to have, because whenever you are going to, as per Six Sigma law, whatever the things you are going to get produced, it is not going to be like 100 percentage pure, 100 percentage it will come out of the original thing. However, somewhere in any of the places you are going to have a defect onto that. Maybe if you're going to take for a particular product, you'll be having a defect. Or else if you're going to make like a 500 meter iron sheet or steel sheet, you'll be having a defect at particular point. You could not able to have an visual inspection for throughout the thing that okay, where is the thing is there, where is the defect is over there, because you don't know where is the defect. So the methods to find the defects are can be found using this non-destructive testing. Yes, any of the charts. Walaikum Assalam, Syed. So this will be going ahead with the right now with the expansion contraction. I'll be going ahead with the thermal expansion and thermal contraction. So whenever we have crossed these bridges like flyovers, we could have made them whenever you're traveling the car or else bike, you'll be getting a sound whenever you are traveling the bridges. So that bridges is actually a part. It is not a normal stretch road which is being built across. So it is like a part, even say for an example, 250 meters of bridges will have an at least five parts. So for an example, it will be having a five parts of 50 meters each. So in the particular part, I'll be having an particular spaces same like this. I'll be having the spaces. These spaces are made during the summer. Obviously, your uh, bridges are going to expand. The same way your railway tracks, you'll be getting the sound whenever the train goes on in the track. So during the summer, you'll be having that. You'll not be having that during the winter. You'll be having the normal sound. Just because that during the summer it will be of the loose end. During the winter, it will be like strong gripped and it will be like expand. So expansion is nothing but when the material is heated, when it's exposed to heat, same like that that particular iron, whatever is being used, particular iron, steel, or whatever is being used, that melting point could have been like 1100 degrees Celsius, but that is not required when it comes to like bridge part ka thing, because the thing is going to be like 30 degrees Celsius or 45 degrees Celsius. It is going to get heated for the over particular period of time for the 3 or 4 months of time. So obviously the iron, whatever you are using, the material which is in between are going to get expanded. So this is what an thermal expansion is. And contraction is nothing but so as you can see here, your electrical cables in the during the summer it will be loosened. When it comes to like winter days, it will be like contracted, it will be too tight. So if I'm going to say like okay, I'm not going to waste like 5 inches of cable wire extra. Obviously, that will make tighten over there and it will be torn at a point. So this is where the contraction and expansion comes into scenario. So wherever the materials like whatever the materials have been used, you have to know the melting point and what are their characteristics. So you have to act according to that. Then we'll come to this stress and strain. So, same like that, we'll come back to the psychological term. I'm having a stress. I have lots of work. I had a stress. So, for the physics term, it is stated as stress is the internal force per unit area inside the material caused by an external load. So, same thing is here. What is the thing is that internal force you are getting tensed when you got stress. You are going to have tensed or you are going to get moved out inside the material. You are the particular material over there caused by an external load that might be because of your work, because of your workload, or else from your parents and whomsoever. So we'll just compare that same thing to here. Stress is an internal force per unit area is nothing but unit area that can be measured in any of the area, like for square or square feet, your centimeter square, cubic meter, whatsoever that particular unit area differs from the place to place, how much ever the place is going to get acted. Because if I'm going to punch it, it is like just going to be like 4 to 4 inches of being acting over there. So I'll be going ahead with inch square. But if something like hydraulic pressure is going to be put on some materials like iron material, you will not be able to make it as an inch square, because that particular square inch will be comparatively more, so that you can either the same like this Newton per meter square. If you wanted to go ahead, you have the large surface of the tension which is going to act on the particular place, you can just have it as a meter. Or else like when it's a small area, you can have it like when you're uh, stressing your pen onto some other area. Like if in the case of your note, that is also stress is being acted onto the particular note, that time you're not able to take that meter square, because you're not having to going to have the much bigger size. You're just going to have the square, you can just use it. So this SI unit, we have then standard term, same like that, how the distance are being calculated in millimeter when it comes to like long distance roads, miles and kilometers are used. Same like that in SI. Pascal is being used for the stress. So it will be calculated as Newton per meter square. So its stress is nothing but how much force I'm going to act, how much force I'm going to give on which area. And then when it comes to strain, the strain which is being applied due to then stress is called as a strain. So strain is nothing but a deformation per unit original dimension, how much the original dimension is going to get deviated, whether if I'm going to poke my pen on my note, how much original dimension is going to get changed, how much dent I'm going to have in that. Or else if any hydraulic pressure is going to put onto that, how much meter square I'm going to have. So it is nothing but change the length versus the original length. So how many what is the total area of I have made the deformation divided by your original length, what was the actual length. For instance, you can take it like I'm just punching the car, so dent occurs. So whomsoever the punches with the hard punch, the dent occurs over there. So how hard you punch is a what force, how much force you are going to give is called as an stress, and how much area that particular car is going to have the dent is called as an strain. Got it? Hope there is no doubts, because this is just a basic. More than the further we go, it will be confused than this. So stress and strain will be related to the same thing, but it's different. So same thing, tension and elasticity. It is also going to be. I'll explain you. I'll make you to explain with the examples. When I'm going to have tension and elasticity, it is like same. It is going to be like a common normal one. But you have a minute gap over there, whereas tension, which is been the force is being acted from the outside. So you are going to pull the box, you are going to push the box away, or else you are going to tie a rope on the box, like maybe a crane. You can use a crane. So what is the force are you going to use to pull that particular 500 kg ka box is what is tension. And when it comes to your elasticity, whether whatever I'm pulling it, tension is nothing but which is happened due to your external force is called as a tension. So elasticity is nothing but which talks about your characteristics of the particular material. Say for an example, you have an rubber band with you. Rubber band, you are the external force who is giving the tension, but still when it comes to your elasticity, that it determines the particular characteristics of the material.
നീ ഇവൻ
Okay.
കണ്ണു നോക്കാൻ വന്നാണ്. ഇവൻ കണ്ണു വെച്ചാൽ 2 ദിവസം ഇല്ല. 2 ദിവസം ഇല്ല, കിടത്തായിരിക്കും.
Please mute yourself, whomsoever.
അരുണ്ടായിരിക്കും. എന്റെ മോനെ ഞാൻ അങ്ങനെ പറയുക.
ഇപ്പോൾ തന്നെ മനസ്സിലായല്ലേ? മൈക്ക് അൺമ്യൂട്ടിലാണെന്ന്. Thank you. Anyway, now you have got it. Okay. So pulling the spring, I am going to pull the spring with the tension. So it is called as I am giving some external force to pull that spring. But springs original characteristic is that it will get back to its original position. So even if I'm pulling the rubber band, what pressure, what force am I going to give to that particular rubber band to pull that rubber band is called as your tension. Whereas when it goes back to your same position, that is called as an elasticity. Even your spring or else your rubber band, your rubber material whatsoever, you are going to put it on elasticity. Even elasticity will have a particular range. So when it moves out of it, your rubber band or else your spring is going to get damaged. It won't, even if you are going to trying to pull your spring with a full force, it will not get back to its normal position. So we'll get back to shear and bending. So shear is nothing but there won't be any external forces. There will be two forces acting accordingly. With the same force, two materials will be acting upon. Same like scissors. Whenever you're going, because your thumb finger and your index finger is going to act with the same force, but your material changes its position. Whether it might be like it is not going to get destroyed, your scissor is not going to get destroyed. That is not none of the concern, but still your normal position is going to get deformed. That is what I look into as a strength of material uh, scholars. You have to understand the particular scissor when you are moving out with the force, your normal shape is going to get changed or it is going to get deformed. That is what it is called as a shear. When it comes to your bending, same like so there won't be any top force. Let me explain this bending later with an example. I'll get back to this bending once after completing that uh, pictorial representation. So torsion is nothing but torsion or your torque, whatever you might call. It is nothing but twisting of particular material for in order to have more strength. Even you cannot able to twist the particular material more than like its permitted limit. Even the you can see that in the drill pit you have one, two, three, four, five, and six. 6 times they have twisted the thing or twisted the material. Maybe it can be of iron. 6 times you have twisted the material. So if not in the case, if I'm going to twist it for 8 to 10 times, obviously it is going to get broken. So the same like whenever we are going to construct a home, we'll be obviously we'll be asking that twisted bars, twisted TMT bars. So this is what whenever you are going ahead with the twisted things, you'll be having the more tension, you'll be having the more strength. But you know how much times that particular material will tackle yours. So this is a quick glance of whatever we spoke. Tension. So I'm giving an external force from both of the ends. So this is what the material. So my mid one is like sky blue or transparent thing is your actual material size. So I'm going to give the force from either from the two ends, from the top and from the bottom. It is called as an tension. When you're going to press from top and bottom end, it is called as an compression. So shear is nothing but you are going to deform the particular material in order to attain some any other shape of other material. So bending, the same thing I have said. So this compression, when it comes to compression, it is like top and bottom. It will be acting. But when it's come to bending, it will be acting on the perpendicular direction. So from this way, your compression acts in the between, whereas your tension occurs from the top to end. That is what it has been explained here. Bending occurs when the load acts perpendicular to the length of the beam, causing it to curve. That might get back to its original position, maybe like same explained in the last point, temporary deformation or as a permanent deformation. So whenever you are going to bend your steel scale till the particular position, it will be like get back to its normal position. Whenever you are going to bend the steel scale, it will get back to its normal position. But whenever you are going to bend more than its limit, it will be deformed permanently. So these are the things like main things, whatever said so far is what the main forces which has been acting on the materials. These are some normal, like it is not much used, but still you wanted to know, bearing, buckling, impact load, fatigue. So bearing is nothing but your rivets. You have the two materials on top and down. You are going to press it in order to, you have to attach it through your rivets, screws, nuts and bolts whatsoever. You are going to punch it. So you have to know how much force you have to give in order to make a hole on the particular material. Whether if it is going to be like 2 material, the force could be lesser. It is going to be like a 10 material, your force has to be higher, like hydraulic presses or something has to be used. Same for 2 material, you can just punch it with a normal handheld punch. But for 10 material, obviously you have to use the hydraulic punch to do that. So how much pressure should I need to use? So same, getting back to that Newton per meter square or Newton per square, same the things come here. But still, two of the materials are going to be attached together. It has to be punched or it has to be joined through your rivets, screws or nuts and bolts. So um, buckling is nothing but you'll be having the rubber scale. Many of them could have crossed this term. Will be having the rubber scale, non-breakable scale. Will be having the term because people sometimes when we go for the school, people used to say that teachers used to say that iron scale is not allowed because that might damage someone. And when it comes to like plastic scale, your parents used to scold you because always you used to break it. So that time the rubber scale has come. It will be of a rubber fingy material. So whenever you are going to make that scale on the standing portion, so at what place it is going to get bended, it is called as a buckling. So if I'm going to hold it on, if I'm going to have like 30 centimeter scale, if I'm going to hold it on 15 centimeter, it will be having a slight bend. If I'm going to hold it on 1 centimeter and the top sorry, a bottom most, your scale would be bending much. So that is called as in buckling. Same, this will be applicable for iron sheets, iron ore, steel sheets. Maybe they'll be manufacturing for 500 tons or 1000 tons. But whenever you are going to make a sheet to be stand over than the particular place, obviously it is going to get folded, get bended on particular places. So impact load. Um, so impact load is nothing but your force, the same force. So you could have played a game called a slap or case. You could have played that game. So when you are going to slap that, you'll be slapping slowly. So that is also called as a slap. But whenever you are going to slap him like with the force, with the utmost force, it is called as an impact load. So a sudden force is going to act on a particular body. So you are the internal body, your hand is your internal body. With the force applied, your brain has asked you to slap him, the slap the external body with the full force. So the same like this when it is coming to the material side. So same like that, shock absorber, you have to change repeatedly, look onto the shock absorbers things. If not in the case, so you are going fastly, if you're going like normal 20 kilometer or 30 kilometer speed, if you're going to take a small bump or else like a speed breaker, it will be like so smooth and soft. But if you're going ahead with a 120 kilometer and the same speed breaker, if you're going to cross that, your shock absorber would get damaged. This it is because of the same force is going to act on a particular body in the repeated faster time. So static load is like same like you are acting on 20 kilometers. It is like a static load, like it's a normal base load. It is going to act. So it is going to be an impact load. The total pressure is going to be applied on the particular external body on the faster moment. So fatigue, people who had traveled through flights, they would have seen that whenever you got a window seat near to the wings, you could have seen that your wings would be flapping on the front and to and fro motion on the top and down. It will be flapping. So it is called as an fatigue. Even that has a particular limit of that. These many times only these particular things has to be this particular wing has to be undergo fatigue because at a particular moment, even after 1,000 times, 10,000 times, a lack of times, your material is going to lose its strength. So now we'll get back to the third question, whatever we have discussed. Why strength of materials? So factor of safety, we call it as an factor of safety. So factor of safety is nothing but an maximum strength of a material and divided by actual working stress applied to it divided by maximum strength of a material. So if I'm going to have a maximum strength of, like, for an iron scale, if I'm going to have like 10 Newton per meter square. If I'm going to give some 12 Newton per meter square, that obviously it is going to get break. So you have to know, okay, for this particular material, for this particular scale, 10 Newton per meter square is the should be the force has to be applied. So you have to be act accordingly. Same like that, it provides a margin of safety. Now, if I'm going like 10 Newton per meter square, so that is what my margin of safety. More than 10 Newton per meter square, I should not apply any of, even like not like 10.1, not 10.2. That not right now it will be get affected. Maybe in the later days it will be getting affected. So we'll get back to the second part, which is of non-destructive testing. How we are going to, there is actually two things called as destructive testing and non-destructive testing. Destructive testing I will cover in the last. So for the non-destructive testing, it is like you are not going to damage a particular part. Like, you know that that particular steel scale is going to have the stress only of 10 Newton per meter square, but uh, because it's a human nature mentality that what if I'm going to apply 12 Newton per meter square? Obviously, we'll have that. Everyone will have that. What is going to happen? Let me see that. Let me wanted to do that. But NDT is all about without causing the damage to that particular material. You are going to inspect that material whether it can be like your shape deformation, any of the dent has caused, any of the, like, even when you're going ahead with the welding, some places welding would have been missed out, um, because in that light welding light you could not able to see that particular places whether it has been solved or not. Once after it is being cooled only you could able to come to know, so we cannot able to take decision that okay, I have made a proper thing. So that's why NDT is being used. So why NDT is necessary? So as said, like cracks, voids, porosity. So same like that, from the when you're going ahead with the welding, for the outer layer it will be like normal. Okay, it is like normal welding. But inside there will be porosity, there will be a gap, air bubble will be formed. Whenever you go ahead with the painting of the cars, you'll be having the air bubble inside. So that is what we wanted to know about. But painting though we could not able to do NDT. For this materials we could able to do like materials whatever we have, we can able to do NDT. So the most things we have in NDT is like four things. There are around 12 to 15 NDT tests are being done, but still four tests only we right now we are looking in further. It's like basic to an advanced method. So when it comes to like we'll be on the for the slides, we'll be looking at with the four types, which is of visual testing, dye penetrant testing, magnetic particle testing, and ultrasonic testing. So VT, DPT, MPT, and UT. These are the normal abbreviations you use. So visual testing is nothing but it is all the simplest of all NDT. It is everyone you could able to find. You can say that this particular material has a dent. They haven't made this properly polished. They have the air bubble. With your naked eyes or else like cameras, your magnifiers, you can able to say that without usage of any of the electronic items or electrical items, you could able to come to the conclusion by touching it or like by seeing it. You could able to come to the conclusion that okay, this particular place, this particular material has got damaged. So same like that, limitations, defects can be only with the naked eyes we are going to see that visible defects. Maybe we cannot able to see what is happening on the inside. If you're going to have the 10 mm plywood, you cannot able to see whether all the places inside it is being sealed properly. Sometimes uh, there will be a gap inside it. It will not been properly stitched. It will be only visible on the top layer, not on the bottom layer. So dye penetrant testing. So it is somewhat advanced to your visual testing. So whatever we are going further, it will be advanced compared to each and every testing. So visual testing is the basic thing. And when you come with DPT, you are going to find the new cracks. Okay. Now with the visual inspection, you have find out that you have the crack over there, but you cannot able to put your scale or somewhat any other measuring instrument that you wanted to know how much deep the crack is. So that time we'll be using going ahead with the DPT. So what is the procedures? We'll be having the six procedures. Surface cleaning. Surface has to be clean. Penetrant. So this will be like normally like colored or fluorescent liquid is applied on the top, like inside it will be poured on the particular crack. So dwell time. So allow some time for that penetrant like fluorescent liquid to get dry. Remove the excess penetrant. Same like that. You'll be out of the layer. You'll be having some excess penetrants will be laid over there. So you have to clean over there. Now we are going to apply developer. Developer, I'll explain on the next slide why developer is important. And for the inspection, crack appears on the colored lines. So for this, as of now, even with the fourth place itself, after applying the penetrant, I could able to know where is the crack. But still, after applying the dye developer, I'm going to have the exact crack at the places. It will be highlighted same like this. Same like this is also going to detect only the surface defects, but still you could able to mark it where are the defects and how much deep it is. So you could able to find out when your cracks or dent is being cut from the outside layer, not from the inside mid part. So MPT. So this MPT can be only done for ferromagnetic. Ferromagnet is nothing but your whatever the material, your magnets are going to get attracted. Because aluminum is not a ferromagnetic material because it is not going to attract any of the magnetic materials. So only MPT will be only used for ferromagnetic. So like for example, iron, nickel, cobalt, steel. So these are the ferromagnetic materials. I'll explain with an example. So right now I have a crack inside. So same like that in the particular for the rest of the places, I'm going to have the North Pole and South Pole. Same like this, it will be looking like this is a North Pole and this is a South Pole. So you are going to give a magnetic induction over there in the particular places. So if there is no cracks, it will be having on the straight line. If there is going to have some crack, your magnetic path will be deflected out of that particular area. So that you could able to know that how much deep is the crack and same like that, your dye penetrant testing without using any of the dye penetrants, you're just making to about to have your MPT on the top, and you're going to find it out. And ultrasonic testing is somewhat advanced compared to your magnetic MPT. So in this, for the sideways, you are going to from the sideways. It is being kept on the top side. So it is kept on the top side of the material and is going to detect. So in this, you'll be having the rays from second. So in this, you'll be having the rays from this side, from the depth. So rays will be passed from this end, and when it is going to don't have any of the cracks or any of the dent or flaws, any of the porosity which has been not available in the places, it will be like a normal initial pulse, and it will be like normal straight line. When you have when you are going to have a crack or flaw somewhere over there, your magnetic material, your whatever the uh, radiation you are giving from this end, it will be getting reflected because there is no places for it to conduct from this side to that side. So with the crack, it is going to get reflected and it is going to get back to your your transmitter. This is a small difference between, so same thing. You're in that you'll be having the magnetic field. In this, you'll be having the sound waves or the sound waves. More advanced methods are there. In that, they'll be using radioactive materials as well. So right now for MPT, I'm going to I'll differentiate MPT versus UT. So MPT uses the magnetic field, whereas this uses the sound waves. So it is only on the surface or which is near to the surface defects, whereas your UT defects, whichever your porosity, there is some hole or something which is not been fixed on mid of the material also, it is going to find out and let you know. So MPT will works only on ferromagnetic materials. As said that magnetic particle testing will be working only on ferromagnetic, not on other like wood or plastic. You cannot able to do with MPT, but still this works on most of the materials like wood, plastics. Even you could able to use it on aluminum, whereas you don't have it is on not on ferromagnetic material, but still you could able to use UT for this aluminum kind of things. This uses magnetic particles, and this requires electronic equipments like an transmitter and a receiver to get your transmitter will transmit the sound waves from one end. If there is going to have a crack, it is going to reflect back the sound waves to the receiver. So that's what you requires both of the thing. So this requires an electronic equipment in this limited penetration depth, say for an example like 1.5 or 2 only that kind of depth, like I said earlier, detects a surface or near surface defects only. It is not going to detect which is what is inside. Same like that, a limited penetration depth and a deep penetration is also possible through this cell. So for this, when it is going to like detects the surface, but because there is a surface instance, because your is going to be on a surface end, like it is on the top of the particular material, so you'll be having the visual interpretation of that. Okay, this particular place has the crack, but when it's going to be having like a porosity, you cannot able to find out where is the particular dent or the material is been getting defected. So this is more far compared to complexity compared to your MPT. Is because you cannot able to find it. You have to run all your UT machine throughout the 500. If you have 500 meter for iron ore or iron sheets, you have to run all the way for all the 500 meters. This then only you will come to know that particular places this has been done. So other entities, these are all the other entities has been used, but not in the normal regular usage. So radiographic testing, eddy current testing. So this is what current testing, as I said earlier, that is based on your sonic waves, sound waves. This is based on your current testing. And leak testing. Leak testing is nothing but you close a jar and you put some water onto it. Some same like that puncture. Whenever you have the tubed tire, you are going to have over there, and you are going to find out after once the puncture is been made resolved, you are going to find out whether any leakage is there. Again, the air is being getting leakage from another place. That is normally called as a leak test. So same like that here, as I said. So compared to your NDT, your destructive testing has lots and lots of types. It will be having, as I have said, it is only 7 types. I have said like tensile, torque, compression, extraction. So these are 7 maximum types which has been used. Forces has been used on for NDT. But still, when it comes to destructive testing, there are more of the tests have been used, like around 15 to 16 tests has been used. So if you wanted, I'll just put you on a separate class for destructive testing. But destructive testing is nothing but in non-destructive testing, you are not going to damage any of the material, and you are going to find out what is the defect over there in that particular material. But in when it comes to your destructive testing, you will be damaging whether that can be a sample material. I have made an so for an example, 500 meter sheet I have. So for that, I'll be having like for first when I'm going with a client, I'll be having for 30 centimeters, I'll be having that sheet for an sample. So with that sheet, they'll be having this testing. So they'll be having that penetration testing, all testing will be done. So this is restrictive testing. You will be loading a particular force on that material in order to know that whether how much force this particular material is going to withstand. So that's it from my end. If I was fast at somewhere else, that's the reason I said you in the first that if you have any queries or you did not understand anywhere, please do stop me at the moment. At least your chat box is open for you. If you feel uncomfortable to unmute your mic, you can just post it on chat box. So it is like a vast topic. Even like strength of materials, NDT will go for like even that particular subject will go for like a particular semester. We have gone through it NDT. So just wanted to give you a basic things. So anything from your side? We have another 8 more minutes. Happy to see people leaving the meeting right now, classes right now. Happy for you. Okay, let's ignore them. And if you have really queries onto that, please do post on the chat box, or else you can just ask me. Hope there is no clarifications or doubts has to be made. So how do accept criteria differ on ASME, API, AWS standards? Could you please just give me a minute? Because I have to look. I'll open onto it. I'm not aware. Let me just read through or go through the ASME API thing. Just give me a minute. Okay, I got you, Jitin. Yes, I got you. They have their standards for the particular product, not for the materials. ASME, API, AWS are the standards. Like if you are going to build a product, say for an example, if you are going to have a vessel, if you are going to have an air turbine, which length is of 15 meter, you should have some standards that it has to go through this fatigue. It has to go through some stress. Sudesh, how come you also have the same doubt? Okay, fine. Answering you all. So they have the standard for the product, not for the material. Material can be tested. That depends on from the client to client. Whether are they going to use a lesser or else a higher standard depends upon company to company. Even all the windmills or the turbines, whatever the flight engines, whatever you are going to use, it is not going to have the same thickness. Even that is not as per the standards. It is all the standards as per the engine manufacturer. They require it, so they'll be manufacturing that. Outsourced people will be manufacturing and giving to them with the standards with that has to withhold the particular stress. This applies for your ASME, API, AWS will apply for your product, not for the material.
Hello, Mr. Nanda, this year. Thank you for the explanation. Just want to ask if these API standards are applicable in our country as well. I mean, in India. I
Sorry,
believe
API
this is
standards?
applicable. This API is applicable in all over the India as well, right? Or it's only for the specific oil and gas fields in abroad?
This is actually made for their standards. Like even we have our ICAO codes, which has been globalized all over the places. That can even how come ISI came into scenario? ISI is only for India, right? So you could
Exactly,
able to
exactly.
say
Yeah.
that it's a product for outside. It is a product which your helmet comes out of ISI. Even if you're going to sell the product in Sri Lanka or else Malaysia, Singapore, you can say that it has the certificate, it has the ISI certificate. But still, how? reliable it is for their culture is the matter. Because our speed of the vehicle is different and their speed of the vehicle is different. Is this helmet, is this, even though it is being certified, is this helmet is going to withstand even like 200 kilometer speed or 300 kilometer speed if they are going to get crashed? Are they going to satisfy that? If so, they'll be accepting that. There are, because once it is being globalized, the thing is being globalized, like how UN is being there for the whole world, it can be done. But when it comes to our standards, we will be testing for us. For them, it is AP approved, but for us, we will be testing it back to back.
So the standards acceptance is varies based on that the products and the same time where
Based
we
on
are
the
going to.
products.
Correct, exactly. Thank you, Sudha. Thank you very much.
Thank you.
Thank you, sir. Thank you.
Thank you. So with this winding up, hope there is no clarifications more than this. Winding up this.
Thank you.
Thank you. Thank you very much.
Thank you, sir. Thank you. Bye-bye.
Thank you. Bye-bye. Have a good day.
Okay.